Hello everyone, I'm Tripusparangini. And welcome to our first meeting in the course Logic and Algorithm for the Information Systems program at UPN Veteran Jawa Timur. In this course, we will learn how to think systematically, how to analyze problems, and how to design algorithms that later can be translated into real computer programs. Today, we will begin with the basic concepts: what logic is, what an algorithm is, why they are important, and how they help us solve problems efficiently. To simplify the concepts of logic and algorithms, I have organized the discussion using the 5W1H method. Next, let's define an algorithm. An algorithm is a step-by-step method to solve a problem. Think of it as a recipe. When you follow the instructions correctly, you will get the expected result. Algorithms help us break a large problem into smaller, manageable steps. In computer science, algorithms are the heart of every program. Without algorithms, even the most powerful programming language wouldn't know what to do. Logic and algorithms work hand in hand. When an algorithm is designed with good logic, it can solve problems very efficiently, quickly, and with little computational effort. However, poorly designed algorithms, even for simple tasks, can take too long, use too much memory, or produce inconsistent results. Throughout this semester, we will learn how to evaluate whether an algorithm is efficient or not and how to improve it. We see the key characteristics of a good algorithm according to Thomas H. Corman. A good algorithm must have input, which is the data it receives, and output, which is the result it produces. It must also be effective, meaning every step is simple and executable, and structured, so the steps follow a clear and logical order. Another important characteristic is finiteness. The algorithm must eventually stop after a limited number of steps. And finally, the steps must have definiteness, meaning they are clear, precise, and unambiguous. These characteristics ensure that an algorithm works correctly, efficiently, and consistently. The first characteristic is finiteness. The algorithm must end for all conditions after processing a number of problem-solving steps. When executing a step, the algorithm has limitations, so it must stop the step being processed. And the second characteristic is definiteness. Each step in the algorithm must be precisely defined and must not use ambiguous instructions, as this can cause confusion. The sequence of steps in the algorithm must also be as clear as possible. An algorithm may have 0, 1, or many inputs. Inputs are values or information that are given before the algorithm begins processing. For example, to calculate the area of a triangle, we need two inputs, base and height. Some algorithms, however, don't require input at all, for example, printing a fixed message. Every algorithm must produce at least one output. The output is the result of processing the input. It could be a number, a message, a decision, or even a complex data structure. In simple terms, an algorithm takes something in, processes it, and returns something back. Effectiveness means the steps in an algorithm must be doable and realistic. Every action must be simple enough so that it can be executed in a reasonable amount of time. A step like solve world hunger cannot be part of an algorithm because it's too broad and unrealistic. Effective algorithms use small, precise operations that computers can perform easily. And the last is structured. The steps in an algorithm should be organized systematically. The goal is to make sure the solution to the problem isn't complicated, so it can be solved faster. There are several types of algorithms, and understanding them helps us design solutions more effectively. The three main types we will discuss are: 1. Sequential algorithms, 2. Loop algorithms, and 3. Conditional or branching algorithms. Sequential algorithm. A sequential algorithm follows a straightforward path. The steps are executed one after another, from top to bottom, without any repetition or branching. This is the simplest type of algorithm and is often used for basic tasks. Loop algorithm. A loop algorithm repeats certain steps as long as a condition is satisfied. For example, counting from 1 to 10, checking students' grades one by one, or reading files until the end. Loops are powerful, but they also require careful control to avoid infinite repetition. Conditional algorithm. A conditional or branching algorithm makes decisions. It checks whether a condition is true or false, and then chooses the next step accordingly. For example, if a password is correct, grant access. If not, show an error message. This type of algorithm is essential in almost all computer programs. Here are a few simple tips for writing algorithms. First, remember that algorithm text is basically a description of the steps needed to solve a problem. Second, there is no universal standard for writing algorithms, unlike programming languages. The style we use is called algorithmic notation. And third, because algorithm notation is flexible, everyone can create their own way of writing it. But for easier translation into real programming code, it's best to write algorithms using a structure similar to common programming languages. These tips help ensure that your algorithm is clear, readable, and easy to implement. Next, remember that algorithm notation is not the same as programming language notation. Because of this, pseudocode cannot be executed directly by a computer. Algorithms simply help us translate real-world problems into a structure that can later be turned into code. They are the result of our conceptual thinking, and before a computer can run them, they must be rewritten in an actual programming language. One of the biggest advantages of algorithms is that they are language independent. This means that a single algorithm can be implemented using any programming language. As long as the steps are the same, the result will also be the same. The choice of language does not affect the logic. Because pseudocode is flexible, different people may write it in different ways. But for clarity, it is recommended to follow a style similar to real programming languages. This makes translation into the actual code much easier. Algorithms help us transform problem descriptions into programming solutions. Once the logic is clear, we can translate it into languages such as Python, Java, or C++. This step, translation, is what makes the algorithm executable by machines. Let's look at a real-life example, frying an egg. If you think about it, this activity also uses an algorithm. You prepare the ingredients, heat the pan, crack the egg, add seasoning, cook it, and finally serve it. If any of these steps are skipped or performed in the wrong order, the result will not be the same. For example, we delete for step 5. In this modified example, one step is incorrectly placed. The egg is put in the pan before cracking it. This simple mistake shows how important the order of steps is. In programming, even one wrong step can break the entire application. Algorithms are used by programmers, students, and developers whenever they need to write source code or solve a problem in a structured way. They ensure that logic flows correctly and that the final output is accurate. Logic and algorithm can be used and implement in daily life and technical problem. Logic and algorithms appear everywhere in both daily life and technical situations. For example, when making a cup of tea, you naturally follow a logical sequence: boil the water, place the tea bag in a cup, pour the water, wait, and then serve. This is a simple sequential algorithm. When deciding what to wear, you use conditional logic. If it's raining, bring an umbrella. If it's cold, wear a jacket. If it's hot, choose light clothing. In technical settings, logging into an application also follows an algorithm. The system checks whether the username and password match stored data, and only grants access if the condition is met. Similarly, computers use algorithms like sorting, where numbers are repeatedly compared and swapped until they are in the correct order. These examples show that logic and algorithms guide both everyday decisions and complex computer processes. Logic and algorithms can be implemented directly into programming code. After we design the steps and structure the problem logically, these steps can then be translated into a programming language, allowing the computer to execute the solution efficiently and accurately. If the algorithm is written correctly, the output will also be correct. But if the sequence is wrong, or if there is a missing or incorrect step, the program may produce the wrong output, or even crash. This leads to debugging, errors, and wasted time. This is how an algorithm executes. The process of computerized problem-solving starts with defining the problem, which is any task requiring a solution. This problem is then systematically broken down into an algorithm, which is a precise, step-by-step set of instructions often expressed in natural language, pseudocode, or a flowchart, detailing how to solve the problem. These guidelines are then translated by a programmer into a functional computer program using a specific coding language. Finally, the computer executes the program, following the algorithm's instructions to arrive at the desired solution or final outcome. It's important to understand that a single problem can be solved using many different algorithms. Each algorithm may approach the problem in a unique way. Some are simple and easy to understand but take longer to execute, while others are more complex yet provide faster and more efficient results. In the world of computing, choosing the right algorithm can greatly impact performance, accuracy, and resource usage. Therefore, as programmers and problem solvers, our responsibility is to analyze these alternatives carefully and select the algorithm that offers the best combination of clarity, effectiveness, and efficiency for the specific situation. And then what is the difference between algorithms and programs? A program is a combination of computer statements, consists of a set of instructions written in a programming language. While an algorithm is a systematic method and series of steps in a program. An algorithm is the logical structure behind the program. Programs are written using programming languages. Therefore, it can be said that a program is an implementation of a programming language. So, essentially, program equals algorithm plus programming language plus data structure. The algorithm provides the thinking, while the program provides the implementation. Thank you for joining today's lecture with me, Tripusparangini, on logic and algorithms. Understanding these basic concepts is essential before we move into more advanced topics such as flowcharts, pseudocode, and algorithm analysis.